blockchain developer at XYO. XYO is XY stands for, latitude, longitude, XY on the planet. We also consider Z as altitude and T as time. So we take those things into consideration when we're building this location proving network. And normally I'm sitting, programming blockchain smart contracts for Ethereum. So this isn't my sort of like forte, is getting up and talking to very intelligent people like yourself. And I'm also on kind of the Ethereum fence most of my days. So I hope I'm not offending anybody who's like diehard Bitcoin and doesn't want to hear stuff from the other crew. And I don't want to divide lines either by saying that. So I'm just, it's really cool to hear, some of the things that are going on with Bitcoin Core are super interesting to me, and I think we're all kind of on the same team in general, just in crypto, and I feel that sense from the community here. But yeah, so I've been a blockchain engineer for a year and a half. I started working with Graham McBain, who I think all of you know, working on this company called Layer 1, and we were going to put land on the blockchain. So we started tiling off the entire Earth, and then each one of those was a block using geohashing, and that geohash was a ERC-721 token, kind of like a CryptoKitty. And so then we created some auction smart contracts and some trading smart contracts, and then before we even pushed to mainnet, we got bought by XYO, which is doing a relative location proving thing. So we were doing a very absolute location thing where the whole Earth had each part of the Earth had its own geohash associated, and you could tokenize that. In this world, it's proof of interaction. So we have these little devices. I'll bring one out, and they're pretty standard. They kind of look like the tile. They're for finding like your keys and stuff. So each one of these little things, if you want to pass it around, is just we call it a sentinel, and inside of it is a Bluetooth chip, and there's a little memory, very little bit of memory, and then a blockchain that basically has a couple hundred blocks worth of data on it, and it will record on its own blockchain an interaction with a fellow sentinel. So not just those little hardware devices can be sentinels. Your phone could be running an SDK that is a sentinel, and each of them has their own private key that generates their origin chain. We call that the origin chain, running on those little things. And when they meet, then they add a block on the ledger of their own blockchain. And you can create this relativistic proving network by doing that in a very cool way and each layer is decentralized. So those things are decentralized. Anybody can build one of those with the SDK that we have released out there. And it's all mathematically, the concept just builds on itself. So you have these decentralized sentinels, and on top of that is a layer we call the bridges. And the bridges, this is a long intro, but I'm just going right into what XYO does. Yeah, I don't know if I'll stick to the slides. It's not even up on the thing.
You have to turn the TV on.
Oh, thank you. All right, so I'll stick with it, but more on that later. Maybe we can talk about the stack at XYO after this if you're more interested in how we make sure that there's certainty to location sharing. So when those things interact, it's not the actual position on the planet that we're considering important. It's the fact that the interaction happened, and then that interaction spans out in a mesh network of these location proving sharers, and that mesh network gets bundled up and bridged on these decentralized bridges that bridge it to the internet. And then we have this layer called the archivists that capture all of those data points, and that's a decentralized layer. Anybody can have their own self-sovereign archivist, which is just like a database. You made it happy. You give it a little tap. So yeah, each archivist is its own database, and you can store on an EC2 and make it public for the world, or you can have it, in your home and be storing data that's bridged to your own archivist network that's totally separate and private from the rest of the network. And then at the top layer, we're creating what's known as diviners, and diviners come in and query the network for location information. Did that sentinel hit your cell phone? And if it did, then you can be certain that they actually did. And the network is decentralized at all 4 layers to make sure that, and it's really interesting how we've able to accomplish that. So yeah, we built this location oracle, but what I'm actually going to talk about is not that anymore. I'm going to go on to, because I'm a dApp developer, and hopefully this is interesting to you guys, the decentralized applications and kind of use cases, developer toolkit that I have. I'm hoping there's some budding dApp developers out there that find it, the hurdle to entry is not so high. Then we've created staking and this new concept called bonded staking. So I'm interested to hear what you guys have to say about that, and then I'll leave plenty of time for questions if you guys have them. So starting off with dApps, I think and I don't know if some of this content is very obvious to you, but yeah, the whole concept of these decentralized networks is to remove the middleman, to have this layer of trust that everyone that participates is securing it, and we can all trust that, and do transactions, financial transactions on it, which is really cool. So dApps, in addition to kind of removing the middleman, you don't need an escrow company anymore. You don't need, basically any financial instrument you can think of, you can put into a smart contract, because it's, like I say here, you can easily build bank level software. You can build lending platforms. You can build these, bonds and all sorts of crazy things that we can come up with like capturing the stock market and tokenizing baskets of goods, or anything that you want to put a monetary value to, you can sort of tokenize and create these interesting new use cases quite easily. But the difficult part is really building the off-chain, as it is always, right? You have this great business idea, but you want to build a beautiful website that everyone uses. So the onboarding is still, probably the biggest hurdle to entry, and that's what we're trying to work out in these very complex systems that involve decentralization. So some of the new use cases that are popping up for dApps in our world are these location-based finance and location certainty use cases. So proof of delivery or payment on delivery. It would be cool to pay for a package when you actually have it in your hands, not when you buy it off the store. All the people that are getting packages stolen off of their doorsteps would appreciate this sort of policy where they haven't lost the money until they actually receive it, and it pushes the burden to the deliverers to ensure that it gets there. Other things, I think I listed a few things we're working on here. So shipment tracking, you put one of those little devices in a package, and then anything that it does a checkpoint along the way would be able to be registered and queried in the network from a diviner. So supply chain checkpoints, anomaly detection. So it's not just location we're interested in, it's also accelerometer readings, temperature readings. If you want to ship things and keep them at a certain temperature, then you want to have certainty that the temperature didn't go above, say, like 90 degrees if you're shipping wine, or if you're shipping ice cream, you want to keep it pretty low, otherwise your ice cream is going to get all nasty. So the ability to have a thermometer sensor hooked up to a sentinel that's doing handshakes along the way with other like sensors will add a lot of just new use cases that have never been dreamed up for very cheap. I mean, we're not talking about building this whole new hardware system anymore for these kind of things. It's just putting this software on your Raspberry Pis, or using these kind of things. So also, because there's certainty involved, and the list of things that device talked to, if you put those on police officers, right, and then they can prove who they were with and where they were with in a very legal sense, and you can depend on that information being true, which is, I think, pretty revolutionary for when we start using this in the court of law. Real estate on-chain MLS, that's something that my company is working on right now with Remax in Mexico, because real estate is very insecure to do trades there, and they need some sort of multiple listing service that's a public ledger that people can trust, not people that basically steal listings from each other, and it's just the Wild West of real estate there. So it's a good place to start with capturing some of this data, whether it's it's in our, we have a sort of a side chain, these archivists that you can store it very cheaply. Like we talk about these new solutions that let you not store every single piece of data on the blockchain, but you can host your own AWS archivist, or you could host your own mesh network of archivists and store your data off chain, but still trust that the system will have valid MLS entries for you. And then of course games and mixed reality is a thing that's coming with the VR headsets, the augmented reality. We're talking with an augmented reality company about putting our token in an AR type game where you get paid as you walk around and do AR type activities. And we actually already have an AR game out called Coin that you can download on iOS or Android that pays you XYO. So we have our own XYO token, and you can literally just mine your location as you're walking around, and then that will pay you in a token to be part of that network as you're sharing your data. And no more is it this idea. So wanted to say, just mention self-sovereignty of data is this concept that we're hearing a lot of problems with Facebook and other companies that feel just they can share your data with whoever they want because you've maybe signed some user agreement that says you give away all your information that you're sharing on Facebook. And they're actually in like $3 billion worth of lawsuits right now for breaking and violating certain laws in different jurisdictions. So they are coming under the gun that people are getting smart about their data. People are understanding that it's theirs. They created it, and it's personal, and it's private. It should be private, and it also should be something that you should be able to destroy at your will because it's your private data. So the self-sovereign data is interesting to us. As people are, losing trust in these big central corporations, and as they're doing bad things with your data, it would be nice to take back that control in self-sovereign data form. So we have some tools. This is kind of getting into the development side of things that we've open sourced the majority of our libraries that are ready for public use, and you can find them here at GitHub/XYO Oracle Network. And I'll just briefly mention a few of those. Deploy is a tool I built to basically bundle up, if you're familiar with Truffle, that's kind of the biggest Ethereum dApp development toolkit there is. So this is just something that wraps up Truffle and makes it super easy to deploy your dApp with one or two commands. If you want to create a new token, you basically run deploy init-s ERC721 if you want a 721 token, or a ERC20 if you want a fungible token. So just being able to create a project ready to go. It has Truffle, it has all these things, and you can deploy it immediately to a network. Boom, and you've got your token. You just name it like Kevin token, and then I can start passing it on the mainnet if I really wanted to spend the money. But I think people are kind of tired of tokens. Now we know how easy it is to just make them, and anyone can make them and is trying to make them. It's lost its luster, but it's cool that it's so easy to do now. And it's also super easy to deploy with this tool. You'd basically -L-N. -L will clean the project, -N will say the network that you want to deploy to, and then this -P deploys it to IPFS. And IPFS, it uploads the ABI to IPFS, which is a content addressable storage interplanetary file system. Is anybody familiar with IPFS? It's super cool. It's still in major beta mode, but it allows you to store the entire, like a file's content. Like this whole presentation would be stored in a hash, and that hash can be stored on the blockchain, and you would be certain that that every bit of this presentation was associated to that content hash. And of course it would be stored in a decentralized IPFS network. So this takes your ABI, puts it on IPFS, so if you needed to access that, it's just another way to use the tool. Then you just access it with a browser. You could see all of your smart contracts in this JSON form, which is how like all of the websites now are interacting with the smart contracts, is through a JSON interface called the ABI. Dapper is another tool I built that basically is a dashboard for your smart contract. So you deployed your smart contract with that one command. You can immediately view every function that's available and that's public on the smart contract. And you can start interacting with it on the blockchain in a nice user interface that's at dapper.layer1.co. And Layer 1 was my company's name before this. Dash is a database on top of smart contract events. If you want to have a UI, nowadays people just expect it to be responsive and to be immediate to access the data on it. With the blockchain, you're not so lucky. Most people are going through Infura right now as their API, or you host your own node on like an AWS server or like some other private server, and that's just expensive and ridiculous. It takes a long time to sync these things. So Infura is the way you would go, and Dash connects right up to Infura, and now you have your common Postgres SQL database, or it connects to whatever database, and it will just listen for the events on your smart contracts and store them in your database. And you can do a local store too. So I don't know. These are just tools that are, free and easy to use, and they make life for me much easier. Hopefully, they're not as scary as I'm making them sound. But Open Zeppelin is another one. I'd give major credit to them. They've done some of the coolest advancements in all of smart contract development. Their latest release, now you have upgradability, which we've implemented in a lot of our smart contracts because developers like me write bugs. It's just a fact of life. We miss an equal sign, a comma sign. It's just, there's bugs. So upgradability, you need that until you can get it stabilized to the point where you can release it. And it gives you this more iterative approach to developing smart contracts where you don't have to get the final product just right and deployed to mainnet. You can actually upgrade the logic for the smart contract, and the state of this contract doesn't change. So all the accounts and the balances don't change. So you don't have to migrate all the data when you do an update. You just update the logic for accessing that. And you're like, whoa, that's centralized. That is centralized. But the point is that you're protecting your network, because bugs happen, hackers will find them, and people will lose a ton of money unless you have some upgradability and some. And that was a huge feat for them to be able to bring this, because it's a super cool technology, being able to change the logic contract and have what they call a proxy contract that stays the same address. So you never have to change the address that you're accessing for all of your UIs and your clients, your mobile and web clients. Hot reloading has been much needed. That's now out. So you just make a change to your smart contract, you hit save, and it's deployed locally to your testnet. Boom. You don't have. It's just like building a React app, if there's any React developers here now. And templates and these EVM packages that basically, since you're deploying bytecode and you're just changing the data on the bytecode when you store things on the blockchain, templates just let you pick whatever is already stored there, so you save a lot of the cost of redeploying the same ERC20, for instance. That's its own EVM package now. And everybody that wants to create an ERC20 just deploys an instance of that template, and it saves a ton of gas, a ton of the price of redeploying these things over and over again. And it's creating what they're calling the Zeppelin OS, the Zeppelin operating system. So it's turning smart contract development into sort of like a file system of sorts. And it's one of my favorite things to develop with is Open Zeppelin. So I thought I'd mention, just throwing topics out there. Maybe you guys know more about some of this stuff, I'm sure, than I do, but Casper is coming. ETH 2.0 is supposed to bring us 1,000 times the throughput of the current speed of the proof of work algorithm. So proof of stake is coming. That's something that we're seeing in all these really advanced blockchains. The data on it is, if you want to create like a Ethereum node that's on ETH 2.0, you'd have 32 ETH. You'd put that on like a home computer, and you don't need a supercomputer, you don't need an ASIC, you don't need a ton of GPUs anymore, because proof of stake operates where everyone that's validating these things is getting paid. You don't have to be the first to validate it. You're all kind of working together, and they have more of like it's more like a dividend or interest payment layout than the actual mining reward for each block. So this sort of gives like the estimates of what we'll see if we had a million Ethereum tokens that are used for mining or for validating. This is going to be the issuance rate. This is a suggestion from the Ethereum Foundation. These aren't set in stone. And then that would put the issuance. This is like your inflation rate. So it would grow at 0.17% inflation. And then that means that the validators, because there's so few validating, would be paid about 18% dividend in addition to the token price, as it fluctuates. So yeah, as you get up all the way, this is the maximum total supply of Ethereum. So this would be like if everybody was staking and was validating, then you would get paid about 1.56% annual interest to be just hold your ETH as a validator. Now XYO staking, that's something that's very near and dear to me. I was going to demo a little bit of it, but we could do that, off chain. So the stake on XYO nodes directly. So the nodes, these sentinels and things, you can actually put. So there's a reward system built on top of this whole decentralized technology, just to incentivize people to stake and to inflate the token price and to get people involved more in the network. And so the more that you put stake on your token, if it's used in a highly visible area where a lot of truckers are going by or a lot of supply chain type stuff, or you have your own business running these with a bunch of coffee shops and people are doing check-ins and whatnot, it will allow you to stake your device and get paid every time there's a query made through the system in XYO. And that's kind of neat. And then we invented this thing called bonded stake that is just like a bond, really. We didn't really invent anything. We just built it on the blockchain. And what it allows you to do is to capture stake in what we call network stake. So you can sell it at in a bigger quantity, but it's locked in a bond for a time period of maybe a year or more. And then you could be potentially paid interest for locking it up like that. You don't have to suffer the cooldowns that you get put in when you do staking normally, because bonded stake, we already know that you're captured. You're not, and the point is because when people are buying these tokens, they're using their credit card because we're onboarding now in these packages. We found all these new ways to avoid SEC regulations and stuff that are major pain in the ass, but they allow us to now sell a whole bundle and have tokens in the bundle. But people are still able to do chargebacks on their credit cards. So you have to protect yourselves, because once you give away your token, it's gone unless it's bonded. So there is sort of this issue where they're not able to do chargebacks. And that's why we invented this thing for our network. So it allows you to capture a lot of token in the network, and then you can use that bonded stake to apply to your devices and to your bridges, archivists, diviners, whatever you want to build. And we think that's kind of cool. So the nodes participating in answers to network queries receive rewards. And what we have is this giant side chain that tracks, using a Merkle tree, accounts and balances of that stake and those rewards. So yeah, on that note, I don't know where I'm at with time. Oh, it's pretty good. I would love to open it up for any questions.